Hi, grade nines. Today we're going to do a lesson that talks about another form of the equation of a linear relation. And I am eternally amused that George and Reuben Harper are here. They've spent 20 minutes, minimum of 20 minutes, maybe even 30, trying to find an assignment to do in the binders. So shout out to them for being so vigilant. But hopefully they'll find one to do soon. All right, so today we're going to look at an example here. Two brothers, Mark and Derek, share a Nintendo Wii. They have 12 games. One is going to their grandparents for Christmas break. If the grandparents also have a Wii, in how many ways can the two brothers share the games? Okay, so that's what we're looking at. So how many ways can the two brothers share the games? So what you have to do is you have to look at both the brothers and how many different games they can end up with. So we have Mark and Derek here. So in one example, Mark can be a greedy bugger and have all 12 games. Derek can have none. Mark can have 11, Derek can have 1. Mark can have 10, Derek can have 2. Mark can have 9, Derek can have 3. Mark can have 8, Derek can have 4. Mark can have 7, Derek can have 5. We'll continue the fun over here, and we'll look through some more examples. Mark can have 6, Derek can have 6. Mark can have 5, Derek can have 7. Mark can have 4, Derek can have 8. Mark can have 3, Derek can have 9. Mark can have 2, Derek can have 10. Mark can have 1, Derek can have 11. Mark can have 0, Derek can have 12. So how many different combinations are there here? So if we count them up, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 different ways that the games can be arranged. So there's 13 different ways that the games can be shared. So 13 different ways. Now, how are the number of games each boy has related? Show this relation in words, in a table, in a graph, and as an equation. So we have to represent this relationship in each of those different ways. So you have to be careful, okay? You have to know how to express it in each of these different forms. So in words, it's not that bad. In words, what can we say? Let's just go down a bit here. In words, we can say Mark and Derek together share 12 games. That's how we can say it in words. Now, how can we say it as a table? Well, actually, the table is that up there. The table shows all the different possibilities. Okay, so the table is already done. So we've done words, we've done a table. Now, what would a graph look like? Okay, so we got to take a look at what this graph might look like. So we've got 12. Mark has 0, Derek has 12. Then there's also Mark has 1, Derek has 11. Mark has 2, Derek has 10. Mark has 3, Derek has 9. Mark has 4, Derek has 8. Mark has 5, Derek has 7. They both have 6. Mark has 7, Derek has 5. Mark has 8, Derek has 4. Mark has 9, Derek has 3. Mark has 10, Derek has 2. Mark has 11, Derek has 1. Mark has 12, Derek has none. So those are all the different possibilities. So when we put this as a graph, we need to go ahead and account for all those possibilities by putting those dots there. Okay, so that's what we have to do. Now, we can also represent this as an equation. So how will we do that as an equation? Well, here's what we got to do there. So we have Mark and we have Derek, and it is an equation. So how can we do that? Well, it's not too difficult. If you take the number of games Mark has and you take the number of games Derek has and add them up together, you get 12. Simple as that. The number of games Mark has plus the number of games Derek has equals 12. Okay, that's all there is to it. All right, good enough. You need to be able to take a relationship like this and represent it all 4 ways: in words, in a table, in a graph, and as an equation. Plus, if you see it as one of the methods, you need to be able to express it in the other 3. Now, let's look at this. 2 integers have a sum of 8. Let x and y represent both integers. Here's a table of values and a graph to represent the relation. So 2 integers have a sum of 8. So that means we have 2 numbers, that's the 2 integers. They have a sum, so when they're added together, we get 8. Negative 6 plus 14, well, that's 8. Negative 2 plus 10, that's 8. 2 plus 6, that's 8. If you add any pair, you're going to get 8. And the graph is right here on the right-hand side of the screen. We see that there's dots in those different spots, right? So all that means is that if we wanted to, we could take a straight edge, like a ruler, and connect those dots, okay? So that's all there is. Now, the points lie on a straight line, so it's linear, like I said. If we have one number and we add the other number, we get 8. So again, this plus sign goes here. We have a number for the first integer. That becomes our x. That's our first variable. That's the first thing we're trying to find. Our second integer is the second thing we're trying to find, so that's your y. X plus y equals 8. Both of the letters are on the same side of the equal sign. This kind of goes against how we've been doing these equations so far. When we've talked about other situations, the letters have been on opposite sides of the equal sign. But for this type of linear equation, they're on the same side as the equal sign. Okay? So that's the kind of linear relation that we're looking at today. If you get something like x plus y equals 8, like we have here, then it's going to look like this. I'll just go back up to the top here. It's going to look like this. Okay? It definitely looks like a line. There's no doubt about that. If you connected the dots, you're going to get something that looks linear in shape. All right? Okay. Now we're going to take a look at a couple other things. If we see an equation like x equals 4, then that means that all points that have an x coordinate of 4, or that are 4 units to the right of the y-axis, if it's suitable, we can join the points to make a vertical line. So if we see the line x equals 4, then that means we're talking about this line right here. All these points have an x value of 4. That's why it's called x equals 4. So x equals 4 makes a vertical line. If we ever see an equation that's x equals something, x equals 2, x equals 3, x equals 9, x equals 30, we're talking about a vertical line. Always, 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 always. It's always vertical when we're talking about x equals something. Okay? You want to put a star beside this because this is something that should go on your study sheet when it comes time to study for your test. Okay? Now the opposite is true. If we take a look at an equation of a line such as y equals 3. Now y equals 3 is a horizontal line. In fact, y equals anything is a horizontal line. And y equals 3 is a horizontal line that connects the points that are 3 units above the x-axis. Okay? That's y equals 3. Okay? So let's go ahead and do a couple examples, see if we can see how this all works out. So for each equation, graph it and describe the graph. So we have x plus 5 is equal to 0. So we need to solve for x. So that just means kicking that over here. When it comes over there, it becomes negative 5 because we would add negative 5 to both sides of the equation. So we get x equals negative 5. Now, how do we graph that? Well, x equals something is going to be a vertical line. So that means it's going to be going up and down. So here's another thing. When you draw these lines, you need a ruler. So you can ask the substitute teacher to reach into the bottom right drawer of my desk and give you a ruler because your lines do need to be straight. If you make a line and it doesn't look like a line, you will lose marks. So please use a ruler. So x equals negative 5 would live right here. This is what x equals negative 5 would look like. So that's what x equals negative 5 would look like. Now, how would we describe the graph? So we would describe the graph by saying it is the collection of points that are 5 units to the left of the y-axis. So I'll give you a second to write that down before we continue. Now, we'll move on to the next one. We've got 4y equals 6. 4y equals 6. So, if we have 4y equals 6 and we're solving for y, we have to divide both sides by 4. So that means that y is going to equal 1.5 or 1.5. So then what we're going to do is we're going to draw a line that represents that. Now, of course, if we have y equals something, we're talking about a horizontal line. So we're going to grab a line here, and we're going to make a horizontal line. Now, 1.5 is going to be just above 1, but just below 2. So it's going to be about right here. So that would be the line 1.5 or 1.5. And that's all she wrote. Now, it's not a bad idea to label your lines. So this is line y equals, say, 1.5. And this is the line x equals negative 5. So there's our two lines, all right? And we still need to describe the line that's on the right side. So if we're going to describe that line, we might say that these are the points that are 1.5 units above the x-axis. That's how we could describe those points. So the graph obviously is the part that we play with the grid. We draw that nice straight line with our ruler. We label the equation of the line, and the description is what I just wrote in green. It's the collection of points that are 1.5 units above the x-axis. And we have one more example to do. For the equation 3x minus y equals 12, make a table of values for -3, 0, and 3, and graph the equation. So how are we going to make that table of values? Well, this is x, this is y, and we need to plug in these values here. So we plug in those values for x and see what we get for y. Now again, if we know our patterns, this is going to be pretty straightforward. If not, then we're just going to have to take some baby steps, and that's okay too. So we've got 3 times -3 minus y is 12. 3 times -3 is -9 minus y is 12. I'm going to do switcheroo. I'm going to take the y over to the right and the 12 over to the left. So it's going to be -9 minus 12. And the y comes over to the right and it becomes positive. So y is negative 21. So that's the corresponding value that goes with negative 3. Okay? So now we got to do the same thing for x equals 0. So we go back and we write out that equation, but this time instead of 3 times negative 3, it's 3 times 0. 3 times 0 minus y equals 12. Anything times 0 is 0. So 0 minus y equals 12. So negative y equals 12. Y equals negative 12. So y equals negative 12 when x is 0. And now we'll move on to the very last one. And of course, the very last one is plugging in x equals 3. Now, some of you might be able to predict what you're going to get here. We got 3 times 3 minus y equals 12. 9 minus y equals 12. Again, let's do the switcheroo. Take the y over to the right, the 12 back over to the left. 9 minus 12 equals y. Negative 3 equals y. So y equals negative 3. So now we have our 3 values. So when it asks us to make a table of values so we can graph these points, we can graph this line, it's an involved process. We have to do some math. We have to do some calculations in order to figure out the y value that corresponds with x. And we have to do that 3 times. So now we can graph this line. But when we graph this line, we have to understand something here. Our y values go beyond negative 20. So we're going to want to make a grid that accommodates that. So we need to make sure our y's go up to a minimum of 30 and probably down to negative 30. Our x's don't have to get too wild or crazy. As a matter of fact, we can just make a standard negative 10 to 10 for our x's. You know, that means that this would be 3, 4, 5. That'd be 5. This would be negative 5 right here. Now, if we're making the vertical go up to 30 and down to negative 30, what that means is that every grid square is going to be 3. So that's 1, 2, 3, 4, 5. That's 15. 1, 2, 3, 4, 5. That's negative 15. And now we can go ahead and graph those points. So when x is negative 3, y is negative 21. So that's going to be down here. Yes. When x is 0, y is negative 12. When x is 3, y is negative 3. So there's our 3 points. If you plot your 3 points and it doesn't look like a straight line, then it means that you probably plotted it incorrectly or you made an incorrect scale. But now that we have those 3 points, you can take your ruler and you can connect those dots. So here's our ruler. I'm going to connect those dots, make sure to draw a nice straight line that goes through those points. I'm going to cheat and just do this. Understanding I know that you can't cheat, but there's our line. Here's the other thing to make sure that you include. It is included on mine, but I'm going to accent them and accentuate them. Make sure you have arrows going up and down and left and right to show that the line goes on forever and ever and ever and ever and ever and ever and ever. Because the line never stops. Unlike this lesson, which is just finished. Your homework is on pages 178 to 180. It's questions 4 to 18, and it's worth marks.